Hey, what's up, guys? Chung here again. So this time I want to talk about this LeetCode problem here, number 1423. Maximum points you can obtain from cards. So basically, you're given like a list of cards, and each time, and the number k here. Each time you can remove one card, either from the head or the tail, and and in the end, you can only remove exactly case card. Okay, and it asks you to calculate what's the maximum points you can obtain by removing those K cards. For example, this one here, you can either first time you can remove one, or you can remove six. Second time you have to remove either two or one here. So every time you can only remove from the updated list, either from the beginning or from the end. So so how do you solve this problem, right? You know, if you try to do a DP or something like that, it won't work, right? Because there's no current status to be calculated from the previous status, because the the current status is not it's not fixed, right? I mean, it could be either from the left or from the right. So the key point here is actually this problem is only checking, it's only expecting you to realize it is actually a sliding window problem. Right? So the click here is that if you work closely, right? If you have case, basically you can remove case from either left or right, right? So what does it look like? It looks like this, right? It looks like a sliding window here. So let's say we have a x x x x. All right, and let's say we the k is equals to 3, right? So basically the sliding window, the size of the sliding window is the n minus k. In this case, it's 1, 2, 3, 4. It's 8. 8 minus k is equals to 5, right? Basically, it's just as if there's a sliding window with size of k that's moving from left to right, right? So as you can see here, so that's the first one, right? Because so the first possibility is to remove everything from here. Okay, so O means, okay, I use O to represent the 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 element we remove, right? So that's the first uh possible way, right? Then what? How about the second? Second one is this, right? The either remove the second one is this. You remove the first one and then move this one forward, right? And then how about the third options here? X, right? And then the last one is this, right? Right. As you can see here, so basically the essential for this problem is it's just ask you to convert from well the card you removed to what has been left in this in this array, right? So if you just think it in the opposite way, right? What's left after you remove this k card, right? It's the sliding window we have here. Basically, now the problem converts to since it asks you to find the maximum score you can obtain, right? And then basically since the total of the arrays is fixed, so then the problem will convert to find the minimum sum of a sliding window, right? Which will be pretty easy to solve, right? Okay, so okay, then let's start coding here. And to get the minimum sum of sliding windows, you can either use a pre-calculated uh, pre-sum arrays, right? But that will require the on space, right, to solve this problem, and the on time. Another way is that you can use a running sum variables, and every time when the sliding window reaches to a new point, we just update the running sum. And yeah, either way is fine. Let's try to use the pre-sums, because the pre-sums I found it sometimes it's useful in other like scenarios, even though in this case it gives us like actual space complexity. But let's implement that first. Okay, so to length card points, right? And so if you want to define a pre-sums, right, you need to have a 0 here, because the pre-sum, it means that, for example, if you want to calculate the pre-sum for this sliding window, right, so you need to basically do a pre-sum at this index minus the one before this x, right, which will be what? The 0 in this case. That's why we have to use a starting point at 0 here. And then for each card in the card point here, we simply append this like currency plus whatever we have in the pre-sums, right? The minus 1. So after this, we'll be having like a pre-sums which store with an actual 0 at the beginning, right? And then uh, we just need to have like a minimum array sum, okay? And since we're getting the minimum, I'm gonna initialize it with a maximum sum here. So now if just now the problem comes down. We just need to loop through this running sum, right? So where's the starting point of the running sum, right? So the starting point is we can either use a left pointer or the right pointer. It doesn't really matter. In this case, I'm using the left pointer to do the loop, right? So basically the time for the for loop is exactly the time of k the k plus one. Sorry, the k plus one, right? See, we have three k's, and uh, that gives us like four possible sliding windows here. Okay, so that's why for the left, in range k plus one, right? That's why we do a k plus one, and uh, so we do the minimum array sum, right, equals to minimum, right, of the current one, and what? And with the current left, and we need to find the right, right? So what's the right position? That's the pre-sums uh, left plus n minus k, right? That's we plus the length of the running of the length of the sliding window, right? So we can get the then we subtract our current uh, sums of the left, right? That will give us the running sum the sliding windows sum, right? And then we for each of them, we're getting the minimum of it, right? And then once this for loop is finished, we just simply return what? We simply return the total sum minus this minimum array sum, running a sliding window sum, right? So the total sum is the last one we already saved in the -1, and then we do a minimum array dot sum, right? I do this should just work. Okay. Here, array. All right, let's try to submit it here. Cool. So this one works, but it gives us, it requires like some extra work to do a pre-calculation of this, and then we have to do a like this like get the current right and left, right? And another way of doing this is instead of using the running the pre-calculated pre-sums, we just simply have a running sum here. Same thing, right? Let's do that real quick here. Card points. So I'm gonna have a running sum, right? So at the beginning, the running sum is what? Is the sum of the card points from current to what? To k minus one, k to n minus k, n minus k, right? So at the beginning, the running sum is this, is the first five, which will be a 0 to 5. Yeah, 0 to 4 basically, right? Okay, so that's the our current running sum. Or actually we don't even need to do that. So let's do this. Let's do a left and right. Okay, right equals to 0, right? And for right equals to and number in enumerate enumerates card points. Okay, so we can even save this line here. All we need is a running sum, right? Equals 0. So running sum is we accumulate the num, right? And then basically we check if the so here we can simply do a check if the right minus left is greater than the n minus k, right? Basically uh we loop through from the left to the right, right? And then we only start our task when we reach the 5 length, right? So the right here is like 0 0 1 2 3 4 is minus okay, so okay, this, right? So because we have a n minus, we can do this minus 1, right? So basically if this right it's greater than this, right? We simply do what? We simply move the left pointer to the right side, and then we also do a minus, right? Minus num card. Basically, we update our current running sum, right? Uh, the left, right? And then left plus 1, right? And now here we just check if this one is equal to this, right? Now if it's the same as this one, which means the current running sum window, the current sliding window is exactly this length, right? Then same thing, right? Same thing. Uh, we have a minimum array sum, right? Same thing here. System max size, right? And then minimum dot running sum, right? Then in the end, same thing. We simply return the sum of the card point, right? Minus this thing here, right? Yeah. So this also works basically, and but the advantage of this one is we don't have to be maintaining this one extra on space space complexity here. We simply use like a rolling running sum, a rolling sum here, right? Basically, as long as it has not reached these conditions, we just keep adding it, right? And then if it's the first time when it reaches this place, right, it will just uh, calculate this minimum uh, array sum, right? And then the next time when the right uh, when the sliding window is bigger than the k than the n minus k, we simply uh, shrink this sliding window to the k size, to the n minus k size, right? By doing this, right? Okay, and then once we find the minimum sliding window, and then on the if we do a subtraction from the total sum, we get the maximum cards that can be removed, right? All right, cool guys. I think that's it for this problem. Yeah, very interesting problem. The only thing here is that you have to understand, right? So another way of treating this, another way of treating the sliding window is to think it in the opposite way, right? So what does a sliding window means, right? It means that by removing, right? So the sliding window is sliding window, right? That's what you can see. And on the opposite side, it means that remove any remove any of the numbers or remove any of the elements outside of the sliding window, right? Okay, cool. I think thank you so much for watching the videos and hope you guys like it and at least I do. So stay tuned and see you guys next time. Bye bye.